we'll be discussing about Physics Paper 1 MCQ Paper 2017 May June Variant is 11. The subject code is 9702. A student creates a table to show reasonable estimates of some physical quantities. Which row is not a reasonable estimate? So for the first option, the current in a fan heater. So the current is approximately 12 to 15 ampere. So this statement is true. Then the mass of an adult person. So the mass is approximately 60 to 80 kg. So this statement is also true. Then the speed of an Olympic sprinter runner. So the speed up is approximately 10 to approximately 13. So this statement is also true. But for option D, water pressure at the bottom of the garden pond. So what is the water pressure? We can use the equation to solve it. There is the total pressure is equal to pressure due to water and the atmosphere pressure. So the total pressure is the pressure due to water and the atmosphere pressure that is acting. So what is the pressure due to water? The total pressure minus pressure due to water. So what is the pressure due to water? The pressure due to water is the total pressure minus atmosphere pressure. So this is the pressure due to water. So we know the value of pressure due to water, and we know the density of water, that is 1000 kg per meter cube, that is 1000 kg per meter cube, and the gravitational field strength is approximately 10. So we get a height that is 89.9 meter, and this height is the height of a river. So it is the height of approximately a river, but the pond's water depth is approximately 2 meter. So the pond's depth is approximately 2 meter, but this height is the depth of the river, so this statement is wrong. 2. A particle travels in a straight line with a speed v. The particle slows down and changes direction. The new speed is v by 2. So initially it has a speed of v, but it changes direction and its speed is v by 2. The new velocity has a component of v by 4 in the same direction as the initial path. So suppose this is the initial path, then it changes direction and its speed is now v by 2, that is v by 2. Now for this speed, that is v by 2, it has a component of v by 4 in the initial path, that is in this direction. So in this direction it has a component that is v by 4. So we actually need to find the angle. So to find the angle, that is theta, we know this side, that is v by 2, and since this side is v by 2, so its horizontal component is v by 2 cos theta. So v by 2 cos theta is along the initial path, that is this path. So v by 2 cos theta is the new component. So v by 2 cos theta is the component. So we get the value of theta as 60 degree. So again, basically here we have given the initial speed, that is in this direction. Now due to some changes, the speed is in this direction, and for the speed that is now in this direction, it has a component that is in the initial path. Since it has an initial path in this side, so it has a component in this side and this side, and its component would be, since if we consider the angle as theta, then its horizontal component is v by 2 cos theta. So the component is v by 2 cos theta, and v by 2 cos theta, and its component value is given, that is v by 4. So we equate this to find the value of cos theta, that is 60 degree. Here we have given an equation, and k is a constant, therefore it has no unit. So k has no unit. Then we need to find the value of n. So what is the value of n? So what is v? V is the speed, and its unit is meter per second, and k is a constant, so it has no unit. Then the unit of density is, so first of all, if we write the pressure or the equation of pressure, then pressure is equal to rho gh and divided by rho. So rho and rho cancels each other out. Then g is the gravitational field strength, is same as acceleration, so its unit would be meter per second square, and h is the height. So we write this, and after solving we get 2 to the power n is equal to 2n is equal to this value. Since the denominator or the base is same, so we equate the power. So after equating the power, we get the value of n, that is 1 by 2. So the answer is A. Question number 4. So here we have given some information. Then what would not give a value for displacement, velocity and acceleration? Okay, so area under the velocity time graph. So area under the velocity time graph is obviously displacement. So we get displacement, then gradient of the displacement time graph. So the gradient of displacement time graph, that is displacement time graph, is the velocity. So this statement is true, that we get velocity as velocity. Then the gradient of velocity time graph is obviously acceleration, so we would get acceleration. But the gradient of acceleration time graph is none of this above. We know that the area under the acceleration time graph, is the velocity, but the gradient of acceleration time graph is none of the above. So this could be the answer, that it is not the value from this 3. A ball is released from rest above a hard horizontal surface. So it is released from a height above the ground, that is above a hard horizontal surface. That is this surface. Then the graph shows the velocity time graph for the bouncing ball varies with time, at which point on the graph does the ball reaches its maximum height after the first bounce. So after the first bounce, we need to find the point where it reaches a maximum height, that is at this height. So we need to find this point. So initially at maximum height it has a speed of 0 or the velocity 0, but before it reaches the ground it has a maximum speed, that is at this point. So before it reaches the ground it has a maximum speed, that is at this point. Then after reaching a maximum speed, we know that as it hits the ground, so suppose this direction is positive, that is its downward motion. So after hitting the ground it moves upward, so upward is negative. So upward is negative, so it starts from a negative value. Then at maximum height we know that velocity is 0. After starting from a negative value, the velocity is 0 at this point. That means it is the maximum height after first bounce. So the answer is C. A ball is kicked upward at an angle of 45 degree to the horizontal. So the ball is kicked at an angle of 45 degree to the horizontal. After a short flight, the ball returns to the ground. So the ball then returns to the ground. It may be assumed that the air resistance is negligible. What is never 0 during the flight of the ball? So the ball is at this point. The ball is thrown above the ground and it rises up, then it goes down. So this is the path of the ball, and since it has thrown at an angle, so suppose this is v, then this is velocity v, so this side would be v sine 45 and this is v cos 45. So we know that at the topmost height the vertical velocity is 0, that means v sine 45 is 0, but we know that v cos 45 or the horizontal component of velocity does not become 0 since there is no opposing force in the horizontal direction. That means there is no air resistance or no other force in the horizontal direction, so the horizontal component of velocity remains the same. And at this point, when the vertical component of velocity is 0 but horizontal component of velocity has some value, that is constant value. So horizontal component of velocity is constant, and so it is never 0. Question number 7. The mass of a rocket propelled truck is approximately equal to the mass of fuel in the truck. So suppose this is the truck and the mass of the truck is same as the mass of fuel inside the truck. Now as the fuel is ignited, that means as the fuel is ignited, the fuel is being used, and so the mass of the fuel decreases. So mass of fuel decreases and mass of truck constant, that is K or constant. Then as the fuel is ignited and the truck is propelled along the horizontal track by a constant force, the effect of air resistance is negligible. During a test run, the fuel is consumed at a certain rate. Which statement describes the acceleration of the truck during the test run? So what would be the acceleration? So we know that resultant force is equal to mass into acceleration, and force is constant. So force is constant, so what would be the acceleration? Acceleration is equal to force by mass, and force is constant. And as we know that since the fuel is being used, so the mass of fuel decreases, so the overall mass decreases, and so the overall mass decreases and acceleration is inversely proportional to mass, so acceleration must increase. So acceleration of the truck increases as the fuel is consumed. The answer is B. Number 8. An object is dropped at time t is equal to 0 from a high building. Air resistance is significant. So here air resistance must act and the object is thrown from a high building. Three graphs are plotted against time. The height of the object above the ground, height that means h, then speed that is v, and the magnitude of resultant force that is f. So what would be the graph? So what is the height, speed and the resultant force graph? So first of all, what would be the graphs? So here we have given that air resistance is significant. That means air resistance is acting. That means as the ball is falling, it may reach terminal velocity. So it may reach terminal velocity since the air resistance is significant. So as the ball reaches a terminal velocity means that the speed is constant. So in all these three graphs, we can see that after a certain point this graph becomes constant. So this may be the graph of speed, and if it is the graph of speed, that means terminal velocity is reached, and we know that terminal velocity acceleration is equal to 0. So if acceleration is 0, we know that resultant force is equal to mass into acceleration, so resultant force is also 0. So the force graph would be option X, that is it is the force graph, and if it is the force graph, then the other option that is remaining is the height graph, that this graph is the height graph. And you may say that the height, why the height does not come to 0? Actually it is a high building, so it is a high building, so it would take time for the height to become 0. And as we can see that if after a certain time, we can see that as the graph is decreasing, so it must reach a 0 value. So due to the high building, it may take time for the height to become 0, but this is the height graph. So option X is force, that is what is force? So resultant force is x, and y is the height. So y is the height, that is y, and z is the velocity. So z is the velocity. So the option is C. 9. A student attempts to find the density of aluminium by taking measurements of a rectangular sheet. He uses the equation, so this is the original equation, to calculate density. What is the calculated value of density, which is uncertainty? So what is density? So we know the mass, length, width and the thickness. So we just substitute the values in the equation to find the original value of density. So we know the value of density. Now we need to find its uncertainty. And in all these options, the uncertainty are approximate uncertainty. So we need to find approximate uncertainty in D. So we know that approximate uncertainty in D by D is equal to approximate uncertainty in M by M plus approximate uncertainty in W by W plus approximate uncertainty in L by L plus approximate uncertainty in T by T. So we need to just substitute the values and substitute the value of density in the equation to find the uncertainty, and the uncertainty is approximately 0.2, so it would be 0.2 and the true value is 2.6. So the answer is D. Question number 10. The graph shows how momentum of a motorcycle changes with time. What is the resultant force of the motorcycle? So what is the resultant force? So resultant force is equal to change in momentum by change in time, and we know the change in momentum, we also know the change in time. We need to just substitute the values and get the resultant force as 500 Newton. Number 11 is related to electric field, so this is not in our syllabus. Then in question number 12, a sphere is acted upon by various forces, all of the same magnitude. Which system of forces provide a resultant torque but zero resultant force? So the resultant force is 0 and there is a resultant torque, that means a resultant moment. So for this system, we know that the moment of force is equal to force and the distance between the two forces. So the forces must have the equal magnitude and the forces must act in opposite direction. So the forces must have equal magnitude but acts in opposite direction, equal magnitude but acts in opposite direction, and the perpendicular distance between the forces. So among these options, so this is actually a couple question. Then among this option, we can see that since there is a upward force that is greater than the downward force, so there is a resultant force. Then here is also upward force is greater than downward force, so there is a resultant force, but we have given the resultant force is 0. Then for options C and D, we have given there is a resultant torque or a couple acting. So as the couple is acting or the resultant torque is acting, that means there is a force, that means the opposite force, that means the forces are equal in magnitude but acts in opposite direction and the perpendicular distance between the forces. We can see that there is no perpendicular distance between the forces and the line of action of the forces coincide, so this has a zero resultant moment. But here we can see that the line of action of forces do not coincide and there is some perpendicular distance between the forces, that is this distance. Since it has some distance, so this is a resultant torque or has some resultant moment. Number 13, a uniform horizontal footbridge is 12 meter, so the length of the bridge is 12 meter and weighs 400 newton. So its weight is 400 newton, and since it is a uniform bridge, so the weight is acting vertically downwards from the center, that is 6 meter. It rests on two supports x and y as shown. So this is support x, this is support y. Then a man of weight 600 newton is at a distance 4 meter from x. So the weight of the man is 600 newton and it is 4 meter from x. What is the upward force on the footage from support x? So what is fx? So we need to find the value of fx. So to find the value of fx, first of all, we know the value of forces, but we need to find the pivot. And if we consider this point as a pivot, then we cannot consider this because we need to find fx. And if we consider this as a pivot, then the distance of the force from the pivot is 0, or the perpendicular distance of the force from the pivot is 0. So we cannot find this force. But if we take this point as a pivot, then we can do it. But here we get a fy as our unknown. So if we take this point as a pivot, then fy is unknown and we cannot solve this equation because now there are two unknown in the equation, that is fx and fy. So this would be wrong. But if we take fy as a pivot, then we know that we do not know the value of fy. Since we do not know the value of fy, but if we consider this as pivot, then we know all other forces and the direction and the distance from the pivot. So we can actually use this as a pivot to solve the question. So the distance of fx from the pivot is 12. So fx into 12, this is the clockwise and the anti-clockwise is these values, that is 600 and its distance from the pivot is 600 and distance is 8, and 400 and its distance from the pivot is 6 since it is acting at the center. So we get fx as 2400 newton, that is C. 14, a metal block has a mass of 750 gram. So the total mass is 750 gram, that is 100%. Then 60% of the mass is magnesium. So 60% is magnesium, that is this mass, and the remainder of copper. So 60% is magnesium, that means the remaining 40% is copper. Then the density of the magnesium is 1.7. Then the density of copper is 9. You must consider the units as well. Then what is the density of the block? To find the density of the block, we actually know the total mass, and to calculate the total density, we need to find the total volume. And what is the total volume? So we need to first find the volume of magnesium, that is volume is equal to mass by density. Then we need to find the volume of copper, that is mass by density. Then we need to just add these two volume values to find the total volume, and total density, that is we need to find total density is equal to total mass by volume. So we get the density as 2.51, that is option A. 15. A man climbs slowly at a steady speed to the top of a ladder. What is the main energy transfer taking place for the man as he climbs? So as the man climbs up the ladder, so as it climbs at a steady speed, so we know kinetic energy is equal to half mv square. But since it travels at a steady speed, that means there is no change in speed. Since there is no change in speed, this v is actually speed, not velocity. So since there is no change in speed, so the kinetic energy remains the same, and the energy transfer that is taking place is the chemical potential energy to the gravitational potential energy. So chemical potential energy to gravitational potential energy, that is A. 16. What is the efficiency of the car? So efficiency is the useful energy output. So this is the lost energy and this is the total energy. So total minus lost energy is useful energy divided by total energy. So answer C. 17. A railway engine accelerates a train of mass 800 ton. So the mass is 800 ton and we know that 1 ton is equal to 1000 kg. So we need to convert it to kg. Then it accelerates from rest to a speed of 50 meter per second. How much useful work must be done on the train to reach this speed? So we need to find the work done, and work done is equal to force into distance. So we can find the value of force, but we cannot find the distance. So we also know that work done is equal to energy transfer, and we know that the only energy that is being transferred is the kinetic energy. So what is the kinetic energy? Kinetic energy is equal to half mv square, where half and the mass, that is in kg, into v square, that is speed square. So we get the kinetic energy as 1 into 10 to the power 9 joules, that is C. In question number 18, a mass is raised vertically in time t. The increase in gravitational potential energy EP of and the increase in kinetic energy is this. So increase in gravitational potential energy and increase in kinetic energy in time t is given. What is the average power input to the mass? So we know that power is equal to energy by time. So we know the total energy, that is kinetic energy plus gravitational potential energy. So total energy, that is kinetic energy plus gravitational potential energy by total time, that is D. 9. Water flows from a lake into a turbine that is a vertical distance of 90 meter below the lake. So the distance is 90 meter. As shown, the mass flow rate of water is 2400 kg per minute. So this mass is for per minute. The turbine has an efficiency of 75%. What is the output power? So to find the output power, we know that power is equal to energy by time. So what is the energy that is transferred? Energy is the gravitational potential energy. So gravitational potential energy is equal to mass into gravitational field into height, and we have given the mass for 1 minute. So what is the mass per second? That is 2400 by 60. So we get an answer of 40, that is the mass per second, or for per second. Then we know the mass, we know the gravitational field, we know the vertical height, that is 90. So we get the gravitational potential energy, and power is equal to gravitational potential energy by time. So we know that we take the time for 1 second. So just the energy value by time, that is 1 second, we get the power. So this power is actually 100%, but we need to find the output power, and the efficiency is 75%. So 100% is this value, and the 75%, that is output power, is this value. So this is approximately 26. 26.4 is approximately 26 kilowatt. So the answer is A. Number 20. A wire of diameter d, length L, hangs vertically from a fixed point. The wire is extended by hanging a mass m to its end. The Young modulus E and the acceleration of free fall is g. Which equation is used to determine the extension x of the wire? So we know that Young modulus is equal to force by cross-sectional area, extension divided by original length. So Young modulus is equal to, we can write force as mass into gravitational field strength into length by pi d square by 4 into extension, and we make extension become the subject of formula. We substitute the m, that is mass, g, that is the gravitational field strength, L, that is the total length, this would be L, small l, then E, that is the Young modulus, and we get the expression similar to this in option D, that is same. Number 21. The variation of compression of a spring with the force applied to it as shown in the graph. A block slides along a horizontal frictionless surface, so the surface is frictionless. That means there is no work done against friction or resistive force towards the spring as shown. So the block moves towards the spring. The block is brought to rest by the spring. So the block, after it contacts with the spring, after a while it becomes to rest, or it comes to rest. When the spring reaches a compression of 4 cm, all the kinetic energy of the block is transferred to the elastic potential energy of the spring. Now this is an important point, that when the compression is 4 cm, all the kinetic energy of the block is converted to elastic potential energy. That means all the kinetic energy is converted, all the kinetic energy, that is EK, is converted to elastic potential energy, that is EP. So that means at this point all the kinetic energy is converted to elastic potential energy. So what is the kinetic energy of the block when it first makes the contact with the spring? That means we need to find the initial or the total kinetic energy. So what is the total kinetic energy? We know that when the compression is 4, the kinetic energy is transferred to the potential energy. That means what is the increase in potential energy is the decrease in kinetic energy. So what is the potential energy? Potential energy is the half mv. Potential energy is equal to half force into extension, or half k x square. So we know the value of force, we know the extension, so we can use this expression, and we must convert the extension to meter. So we get the value of 0.16 joules, that is same as option A. 22. A longitudinal wave travels through a long spring. The spring is shown at one instant. What is the wavelength of the wave? We need to find the wavelength, and for a longitudinal wave actually travels parallel to the direction of energy transfer, and for a longitudinal wave, the wavelength is the distance from one compression to the adjacent compression. So the distance from one compression to the adjacent compression, that is B. But for a stationary wave, you must remember that for a stationary wave, the wavelength is from one node to the third node, or this is actually the one wavelength, or from one antinode to this antinode and this antinode. So this is the wavelength for a stationary wave. That means from one node to its adjacent node is half the wavelength, and from one antinode to adjacent antinode is half the wavelength, that is lambda by 2. But for a longitudinal wave, you must remember that the wavelength is from one compression to the adjacent compression, that is option B. 23. A sound wave has a frequency that is given and a speed is given. What is the shortest distance from the point of maximum pressure of the wave to a point of minimum pressure? So from maximum pressure to minimum pressure, that means from maximum pressure to maximum pressure is from one compression to another compression, that means from one compression to another compression. But from maximum pressure to minimum pressure, that means from maximum pressure, that is compression, to minimum pressure, that is rarefaction. So one compression to another adjacent rarefaction. So we need to find the distance from one compression to the adjacent rarefaction, and if we see it, then compression to compression is one wavelength, but compression to adjacent rarefaction is half the wavelength. So we need to find lambda by 2. So we need to first find lambda, and we know that V is equal to F lambda, so lambda is equal to V by F. So we get the lambda, and what is lambda by 2? That is from one compression to adjacent rarefaction. We need to just divide the value by 2 to get the answer as B. Number 24. A sound wave is displaced on the screen of the cathode ray oscilloscope as shown. The time base of the CRO is set as this value. That means the time base, that means the one division or the one box is this value. What is the frequency of sound? We know that frequency is equal to 1 by time period. So we need to find the time period for one complete wave, that is from this point to this point. So this distance is approximately 4 boxes. So we know the value for one box. So what is the time for 4 box? We need to just multiply the value into 4. Then we know the time period, and frequency is 1 by time period. So 1 by time period is 100 Hz. So the answer is B. 25. A car is traveling in a straight line at a speed of 30 meter per second. So the speed of the car is 30 meter per second, that is Vs is 30 meter per second. So 30. Then passes a near stationary observer while sounding its horn. So it passes a stationary observer. Suppose this is the observer and this is the car. Then it again passes the observer. So the true frequency of the sound from the horn is this value. That means the frequency of the source is 400. So the speed of the sound in the air is given. So we know the speed of the sound in air, that is V. So the speed of the sound in air is 336. What is the change in frequency? That is change in frequency of the sound heard by the observer as the car passes. So this is a Doppler effect question, and suppose this is the observer and the car moves towards the observer, then moves away from the observer, and we know the equation, that is FO is equal to FSV, V plus minus Vs, where we need to find the value of FO. And as the object moves towards the observer, so the frequency increases, thus it has a minus sign, that is minus. Then as it moves away from the observer, we know that as it moves away from the observer, the frequency decreases, so it must have a plus sign. Then we need to just substitute the value to get the values of frequency, and to calculate the change in frequency, the highest frequency minus lowest frequency, we get the change as 72 Hz or 71.9 Hz, that is approximately 72 Hz. Number 26. Which list shows the electromagnetic waves in the order of increasing frequency? Increasing frequency means decreasing wavelength. So decreasing wavelength means First of all, it has a highest wavelength, then it has a lowest wavelength. So highest wavelength, that is radio waves, then microwaves, infrared radiation, so infrared radiation, visible light, ultraviolet radiation, so ultraviolet radiation, X-ray, gamma ray, so gamma ray. That means decreasing wavelength or increasing frequency. The answer is B. 27. The diagram shows a steel wire clamped at one end. The other end is attached to a weight hanging over a pulley. So the other end is attached to a weight hanging over a pulley, and the other end is attached at a clamped end. A vibrator is attached to the wire near the clamped end. So at this end there is a vibrator. A stationary wave with one loop is produced. So a stationary wave with one loop is produced, and the frequency of the vibrator is f. So the frequency of the wave or the vibrator is f. That means the frequency of this wave is f. Which frequency should be used to produce a stationary wave with two loops? So this is actually one loop, and the two loop will be that from this point to this point. So from this point to this point, this is one loop, and from this point to this point is another loop. So we can say that the wavelength decreases by 2, since the wavelength is the total length, and now the wavelength decreases by 2. So the frequency must increase by 2, that is 2f. Question number 28. A parallel beam of light of wavelength that is given is incident normally on a diffraction grating. The grating has 300 lines per millimeter. What is the total number of intensity maxima from the grating? So we know that for diffraction grating, the formula, that is d sin theta is equal to n lambda, where we know the value of lambda. And what is the value of d? We have given that 300 lines per millimeter. So in 1 millimeter 300 lines, so in 1 meter this much lines. So this is the value of n, that is the number of lines per meter. And what is the value of d? D is equal to 1 by n. So 1 by n. So we know the value of d and we know the value of lambda. And what is the total number of intensity maxima? That means the total number of intensity maxima is the total number of lines that can form on a diffraction grating. So on a diffraction grating, from the 0th order to the top order, we know that the number of lines that are formed from the 0th order is approximately 90 degree. So from the 0th order to the top order, the angle is 90 degree. So we know the value of angle. So we know the value of sin theta. So what is the value of n? N is equal to 5.55. So we have to take the value of n as 5, because whatever the value is, suppose this is 6.99, then we must take the value that is 6. So it is 6 and the value is not 7. Since it does not crosses 7, so we cannot take 7 as the value, and the value we should take is 6. So in this case 5.55, we should take a value that is 5. Since it does not crosses 6, so we cannot take a value that is 6. So the value of n is 5. And what is the total value of n, or the total number of intensity maxima? We know that from the top or 0th order to the top order, and from this 0 order to this top order, we need to find the value of n. So we need to just multiply the n by 2. So n by 2, and we need to count the 0th order. So n into 2 plus 1. So in total we get a total value of 11. So 11 intensity maxima that are formed. So the answer is C. So 2n plus 1, this is because for this region we get an n number of intensity maxima. Then for this region we would get an n number of intensity maxima, and this intensity maxima are from the 0th order, but we need to must count the 0th order, because in the 0th order intensity maxima is also formed. So this is 1. So 2n plus 1, that is 11. Then question number 29. A pattern of interference fringes is produced using a red laser, a double slit, and the screen. The screen is 3.5 meter from the double slit. So the experiment is in such a way that this is the double slit experiment, and so this is a rough drawing, and this is d, that is the distance. So this from one slit to another slit is a, and this is x, that is from one bright fringe to another bright fringe, the distance is x. So what is the separation of the slits? So we need to find the separation of the slits, that is the value of a. So we know the equation, that is lambda is equal to ax by d, and we need to find the value of a. We know the value of lambda, that is 640 nanometer. We know the d, that is 3.5, but we need to find x. So what is x? X is the distance between the bright fringes. So this is the first distance, then this is the second distance, third and fourth. So x is the distance between the bright fringes. So the fourth distance that is covered is 72 millimeter. So one distance is 18 millimeter, and we must convert it to meter. So we know the value of x, so we need to just substitute the value to get the value of a as 1.2 into 10^-84, that is approximately equal to a, or this is actually equal to a. 30, this question is related to electric field, so this is not in our syllabus. Then question number 31 is also related to electric field, so this is not in our syllabus. Then in question number 32, the diagram shows a symbol for a wire carrying a current I. What does this current represent? So we know that current is equal to charge by time. So charge flowing past a point per unit time. So charge per unit time is the current, so the option is A. Then in question number 33, which values of current and resistance will produce a rate of energy transfer of 16 joules per second. So rate of energy transfer, that is energy per unit time. So rate of energy transfer means energy per unit time, and we know that the energy per unit time is power. So which current and resistance value would give a power of 16 watt? So we know that power is equal to I square R. So we need to substitute each of this value in the equation, and the answer we get is C, because I square, that is 4 square, we get 16, and R is 1, so into R. So the power that we get is 16 watt, as similar to given. So the option is C. Number 34, which component has IV graph as shown? So this is the actual IV graph of a filament lamp, and if we draw the graph and complete the graph, then the graph would something look like this, that it would be this symmetrical graph, that is this side is symmetrical to this side, and this is the graph of filament lamp. So this is similar to this graph, that for filament lamp current is directly proportional to voltage, then as voltage increases current increases, but due to increase in current heating effect increases or temperature increases. Since temperature increases, so resistance increases, that is R increases, and as resistance increases, so current value decreases. Thus after a constant increase it shows a decreasing value, so decreasing value. Then for metallic conductor the current is directly proportional to voltage, so it would be a straight line. Then for a fixed resistor, again this is a straight line graph. Then for semiconductor diode, we know that semiconductor diode conducts in only one direction, and the symbol is in this direction. So the IV graph of the semiconductor diode is this graph. So this is the graph of semiconductor diode, and the graph that we have given is for filament lamp, that is option A. Question number 35, the circuit shown includes a cell of constant internal resistance, that is small r, and external resistance, that is capital R. So this is R. The student records the ammeter and the voltmeter reading. She then connects a second identical external resistor in parallel with the first resistor. Now initially there is only one resistor. Now she connects another resistor that is identical to this resistor in parallel with this resistor. What happens to the current reading and the voltmeter reading, that is the ammeter reading and the voltmeter reading? So in parallel circuit we know that in series circuit the voltage is more, but in parallel circuit the voltage decreases, so the voltmeter reading decreases. And what is the ammeter reading? So in parallel circuit the voltmeter reading decreases, but as current is from this side is transferred to this side and this end, so as current is transferred to some of this end and some of this end, so the ammeter value would actually increase. So the answer is C. 36, a computer is used to detect the change in position of a switch. To detect the change in position, the computer requires a potential difference of 0 volt to its input. So 0 volt to its input at one switch position, and a potential difference of between 5 to 7 at the other switch input. So at one input it requires 0 volt, and at the other input it requires between 5 to 7 any value. So for each of these circuits, assume that the battery has negligible internal resistance. That means there is no internal resistance of the battery. Which circuit provides an input voltage to the computer that enables it to detect a change in position of the switch? So what voltage value do we need? We need a 0 voltage value and a 5 to 7 voltage value. So for the first circuit we can say that since the switch is open, so we would get a 0 voltage value, and we need to calculate the voltage across this resistor, that is V2 is equal to R1 by R2 into V total, or R1 by R total into V total, that is R1 is equal to 1 by R total is this resistance plus this resistance, that is 2 into V total. So we get the V total as 4.5. So this is not between 5 to 7, so this is not the answer. Then for this arrangement again we get a 0 volt, that is for one value, and for other value between 5 to 7, so we need to find it. There is 2, that is the R1 by R total, that is 2 plus 3, so R total is 3 into V total, So we get the voltage, that is V out, as 6 volt. So this is between 5 to 7. So this could be the answer. Then for the other arrangements, we do not get a 0 voltage reading for this arrangement because since this side is open but this is connected to some computer, so this is connected but this side is open, that means there is a flow of voltage in this region. Since there is a flow in this region, so we cannot get a 0 value. Again, we can see that there is a flow of voltage in this region, though this end is open but there is a flow of voltage in this region, so we must get a voltage value that is not 0. So this could not be the answer, but I have just calculated the V out to get an for some reason. Among these options, we would get a 0 volt reading and a 5 to 7 reading, that is 6 in option B. So the answer is option B. Then question number 37, in the circuit shown, the battery and the emitter has negligible resistance or negligible internal resistance. The following combination of resistors are each separately placed between terminals X and Y of the circuit. So these are placed between X and Y. Which combination would give the emitter reading of 8 ampere? So to calculate the emitter reading, we know the total voltage, so we need to find the total resistance, that is the resistance for this combination, resistance for this combination, resistance for this combination, and the resistance for this combination. So the answer should be C. So I just have solved this for C, that is, since they are arranged in parallel but this is arranged in series, so the series resistance is 3 ohm and the parallel arrangement is 1 by 3 plus 1 by 3 and it's reciprocal. So the parallel resistance that we get is, or the total resistance that we get is 1.5 ohm. So we get the resistance as 1.5 ohm. We know the total voltage as 12 volt. So current is equal to voltage by resistance, that is 12 by 1.5. So the answer is A, 8. So the answer that we get is 8. So the option is C. 38. The table lists the nucleon number, that is the total number of protons plus neutrons, and the proton number of various nuclei. The nuclei are represented by the letter L to T. So these are the nucleus, and this is the nucleon number, that is the proton plus neutron, and this is the proton number P. Which row in the following table correctly shows 3 nuclei? So 3 nuclei of the same element, so of the same element, and 3 nuclei that have the same number of neutrons. So nuclei of the same element means they have the same number of protons. So same number of protons in this, or either this, or this, or this. So the correct answer is option A, because we need to select. So the answer is A, that is L, M and N. So L, M, N, and the same number of neutrons. So the neutron number would be the total number of protons plus neutron minus proton is the number of neutron. So we need to subtract each of this value and we would get the same number of neutrons in N, P and R, that is 136. So the answer is A. Number 39, a radioactive nucleus is formed by beta minus decay. So as beta minus decay occurs, we know that in beta minus decay, neutron changes to a proton and an antineutrino is emitted. This nucleus then decays by alpha emission. So after beta emission, alpha emission occurs, and alpha particle has 2 neutrons and 2 protons, so 4, 2. Which graph shows the nucleon number, that is the total number of protons plus neutron, plotted against the proton number, that is P, and that shows beta minus decay followed by alpha decay. So first of all, beta minus decay occurs, that means in beta minus decay, neutron changes to a proton, that means proton number must increase by 1. So here we can see that the proton number increases by 1. Then as alpha decay occurs, proton number decreases by 2 and neutron number decreases by 2. So proton number decreases by 2, that is from 92 to 90, and neutron number or the nucleon number decreases by 4. So the nucleon number, that is the proton plus neutron number, decreases by 4, that is in this graph. So the nucleon number decreases by 4, that is 234 to 30, and the proton number decreases by 2, and so this is the answer. In question number 40, what are the structures of proton and neutron in terms of quark? So proton consists of up, and down quark, and neutron consists of up, down quark. So proton contains 2 up quark and 1 down quark, and neutron contains 1 up quark and 2 down quark. So 1 up and 2 down. So the answer is C.